doing FSC 115, introductory phases 1. Okay, so let's see on vectors. We have vectors. So we complete vectors. We complete vectors today. I give an assignment. So the assignment I give you, who can read it out? Because I think all of you did not get the concept. You all got the answer correctly. Your diagrams were wrong. You gave me wrong diagrams. So I will explain to you how it is drawn. If you have a dispatch rider, that's the question. A dispatch rider, yes, follows the following routes. Please continue. To deliver a package. So, first one, the following route. 12 kilometers to the east, yes. 7 kilometers northwest. Is it northwest? Okay, northward, okay. Northward. Two kilometers, 30 degrees north of east. So, you have to find what's the question? You have to determine the displacement of the rider. You have to find the displacement of the rider. Displacement of the rider. Okay, so that's the question. Now, just first understand that displacement means from where you were to where you are. Displacement means from where you were to where you are. Where were you at the starting point? Where are you at the end? That is the meaning of displacement. Can you mute yourself, please? Can you mute yourself? If I'm to go from point A to point B, this is where I am now. This is where I've gotten to. So we say where I was to where I am is called displacement. So from A to B is my displacement. But to go from A to B, I can decide to follow different routes. I can first go certain meters to the south. I am here. When I get to the south, I can move certain meters to the east. Now I am here. I can move certain meters to the north again. Now I am here. Finally, I can now move from A to B. Now I am at B. If you observe something, all they asked me to do was to go from point A to point B. But look at the way I have done it. I've moved from A to here, to the south. I moved from here to here, towards the east. I moved from here to here, towards the what? North. That is how I have decided to move. Whereas, I'm just going from here to here. Therefore, all these paths I followed, that nobody has any business with the path I followed. Nobody has any business. I don't care how you got from A to B. I don't care. All I care about is what? You have left point A, you are now at point B. Distance from point A to point B is your displacement in this case. Distance in quotes. Displacement must have direction. It's a distance in a particular direction. That's what displacement is all about. So, all this, I don't care. This, I don't care. This, I don't care. This, I don't care. My displacement is just what? From here to here. That's my displacement. And take note. For displacement, you must go from one point to the other. Like now, I said at point A, you went south. Yeah, I go south. That's I went south. Then I went east, so I go east. Then I went north, so I go north. Then I went what? Northeast, so I go northeast. This was what all of you drew. Now, this is not allowed for displacement. Because for displacement, you have to leave where you are. You have to leave this place for a year. So you must leave. Here, you have not left. You have set a point. These are cases of forces. Forces can add to the east, can add to the south, can add to the north, can add northeast, without leaving the object not leaving where it is. This is a case where the object is not leaving. These are forces acting at a point. But here, you go from A to here to the south, you must leave this place. Here you are not left, you are still here. You must leave, you are now here. You go from this to this, you have left here, you are now here. You go from here to here, you have left here, you are now here. You go from here to here, you have left here, you are now here. On overall, you are not here alone, you are now here. Is that clear? So you have displaced from here to here. This is what, as me, this was the question. This is what you draw, and not this. These are forces acting on an object at a point. If there are forces, you can draw like this. But God bless you for that. So if there are forces, you can draw all here. You can draw all of them here. You may not leave where you are. But if it's displacement, you must change your position. Why am I dwelling on this? Because all the brilliant students who submitted to me, this was what they drew. It's like this, and not this. Good. God bless you. So let it now. Let it now. Let's go. Let's study. Let this rider, let him start from here. Let the rider start from this place. I want the rider to start from here. He starts from that place. He said, you move what? From where is it? Of course, every person must start from somewhere. The rider starts from here. Let's say point A. He starts from point A. So let's say how he moves. He moved 12 kilometers east. Where is east? This is east of his position. So the guy has gone 12 kilometers to the east. Where is the guy now? Is the rider still here? The rider is now here. The rider has left here, is now here. So when he got here, again, he moved 7 kilometers northward. Meaning, he got here, he moved north. He moved to the north. The rider moved to the north again. He went to the north. He went to the north. It's because of the heights. So the guy has gone to the north. He moved to the north. How many kilometers? 7 kilometers northward. Okay, let me bring that down. Let me bring that. So I can draw it. So the guy started here. The rider started his journey from here. He moved 12 kilometers east. This is east. This is the rider here. He has moved 12 kilometers to the east. Okay? He moved 7 kilometers to the north. Meaning when he got here, he now moved to the north. He moved to the north. Which is what? 7 kilometers to the north. Where is the rider? He left A. But where is the rider now? Where is he now? Where is rider? Is he here? He's not here. He's not here again. He's now here. Have you now? He's now there. This is rider now. We are reading for 2 kilometers 30 degrees north of east. Now, that means the body goes, this is where it is now. It's going northeast. This is north, this is east. So it's going northeast. The body has come northeast. Okay? Where will the angle be? Where will the angle be? Will the angle be to the east or be to the north? Will the angle be made to the east or the north? Good. It's to the east. I will explain that to you now. Let me explain it to the east. No, it's to the east. Listen. Let me explain it to you. If you hear 30 degrees north of east, the angle is always close to the of east. It's close to the east. Always put out for of east. If you say 30 degrees east of north, it will be close to north. Is that okay now? Of north means it will be close to north. If you now see this one, north 30 degrees east. If you see it like this, it will be close to the north. If it's written like it will be close to the north. You have to note that. Very important. Is that okay, class? Is that okay? Is that okay? If you hear 30 degrees north of east, the angle will be close to east. If you hear 30 degrees east of north, the angle will be close to north. Is that okay? If you hear north 30 degrees east, it will be close to north. So the angle, this thing will fall between north and east. This is between north and east. This is my line. But where will the angle be? Close to east or close to north? We agree close to east. Good. Good. Same applies to south of east, south of west, west of south, same thing. South, 30 degrees west, same thing. They will be close to south here. Is that okay, class? Good. Alright. So let's solve this question now. So let's get, yes, please go ahead. Please go ahead. Yeah, look up, don't go far. Don't go far at all. I can't hear you, but I've gotten your point. And don't go far at all. Can you hear me, class? We have true bearing, e.g., 0, 30 degrees. We have compass bearing, e.g., 30 degrees, like this. Now, for all bearing, you will start from the north. All bearing must start from the north. Bearing does not recognize south. Bearing does not recognize south. So if I write 030 for you, it means you go to the north and measure 30. This is 30. If I give you bearing 120 degrees, you go to the north and measure 120. Is that okay? If I give you 290 degrees, you go to the north and measure 290. Is that okay now? Bearing must start from the north. From the north. Now, if it's a compass bearing, if I give you north 30 degrees east, you go here, you put between north and east and put 30. If I give you south 60 degrees west, you go between south and west. You put it here. It must be close to south. Angle must be close to south. Is that okay now? Is that okay? That boy? Very good. Very good. Sure. So for this one, this is not really bearing. It's not really bearing. This is physics. It's not bearing. Okay? Even though it looks like bearing anyway. So let's go. Summation ds, meaning summation of all the, what's it called? Displacement along the x-axis. This is it s or y or s and y? This 12, is it x or y or s and y? Is it x or y or s and y? It's x. It's x. Is it plus s or minus s? Yes, please. No, just watch the video. I will send the video to you. Is that okay? I will still send the video because the network has been so bad for us today. I'm not enjoying the network at all. But yeah, if you still listen to me, you'll get it also. Is this x or y or s and y? Is it plus s or plus y? Is it plus s or minus x? So this is plus 12. This is plus 12i. We'll call it 12i. 12i. That boy, anything that looks like this is plus x. Anything that looks like this, that boy, is minus x. Anything that looks like this is plus y. Anything that looks like this is minus y. Anything that looks like this is x and y. It's like this is x and y. If it's like this is x and y. If it's like this is x and y. That way, did you get that summary? Now, this 7, is it x or y or both x and y? Okay, so we have done 12. This 7, is it x or y or x and y? This 7. Is it plus y or minus y? So there's no s. It only have x. This 7 does not have s at all. The 7 does not have s at all. These two, is it s or y or s and y? X and y. Yeah, what's the s value? What's the s value? 2 cos 30. What's the y value? 2 sine, 30. What's 2 cos 30? Yeah, punch and give the answer. 1.73. What's 2 sine 30? 1. Is this x? Is it plus or minus? Is it y plus or minus? They are both plus. God bless you. Because you are in a place where s is plus, y is plus. Positive and positive y, s and y axis. So let's go. So what's the s value? Plus 1.73 I. Who knows what this I mean? What does I mean? Good. I is called unit vector along the x-axis. I is called unit vector along the x-axis. Good. So what's the answer? 12i plus 1.73i is what? 13.73i. Let's see summation of dy. Summation dy. Yes, it's faster. I means unit vector along the x-axis. A unit vector is a vector whose magnitude is 1. We use I to indicate that this vector is 12. Its magnitude is 12. I means is along the x-axis. The vector is magnitude 12 along the x-axis. That's what the I is telling us. This 1.73 r, meaning its magnitude is 1.73, is along the x-axis. Let's see dy. Let's see dy. Let's see dy. Oh yeah, class. Help me, class. Is this 12s or y or s and y? Does it have y at all? So 0. There is no y. God bless you, 0. This 7, is it s or y or both s and y? Is it plus or minus? Because it's positive y-axis. It's positive y-axis. This positive y-axis. Now, these two, is it s or y or both s and y? Both s and y. That's what? Is it plus here or minus? Plus 1j. I mean now? Plus 1j. I wrote j plus 1j. Answer is now what? 8j. What is the resultant displacement now? Resultant. I will say in unit vector notation. Please pay attention. In unit vector notation, the resultant D is 13.73i plus 8j. If I present my answer, in unit vector notation, this is what I get. Are you following the class? But in magnitude notation, in magnitude, which I taught you, in magnitude stroke direction, magnitude and direction, my D is square root of, give it class formula, summation dx all squared plus summation dy all squared. If it's force, we'll say summation fx, summation fy, and we'll say resultant. If it's displacement, we say dx. Yes, please. Yes. Good. This unit vector notation, meaning in terms of I and j. Who can interpret this one for me? Who can interpret 13.73i? Who can interpret it? 13.73i. Who can interpret it? That means that what? The rider moved in total 13.73 kilometers along the x-axis. Along the x-axis. Who can interpret 8j? 8j. That means along the, God bless you, the rider moved 8 kilometers along the y-axis. That's the meaning of that. So let's go. Your D is now what? Square root of, what's your dx? 13.73 squared. What's dy? 8 squared. We have punched this on calculator and give the answer. Yes, square of this plus square of this, add together, find the square root, give me the answer. No, it's not possible. You can't get 8.2 kilometers. 15.89 kilometers. What direction of a displacement? How do you find direction, class? How do you find direction? That theta equals arctan of the y part, summation dy, over summation what? Ds. That means what? Arctan of, what's dy? What's dy? 8. What's ds? 13.73. We have punched this. Arctan of dy over ds. What's the answer? Arctan of y. Press arctan of that angle, of that number. Press arctan. Divide 8 by this. Press the arctan of it. This is our first time of doing this. If you have missed the class, check the videos. I can't hear you. 30.2 degrees. Yes, thank you. Okay, it's okay. 2 is okay. 30.2 degrees is okay. What does this mean? Yes, please. Tan inverse of y value over x value. Your y value is your j value, that's 8. Your x value is your I value, that's what? 13.73. It's always direction of resultant. Direction of resultant is always arctan of y value over x value. It's always arctan of y value over x value. Confirm to me this is clear, class. All right. So what is the meaning of this we have done? Let's draw the guy's displacement graph. Look at the board. The total displacement of this rider is 13.73I plus 8J, which means instead of this merry-go-round, you should have just moved what? 13.73 in the positive x direction, and what again, class? And what? 8 kilometers in the positive y direction. Okay, I said instead of this guy going like this, going like this, going like this, the rider. So instead of this guy going like this, like this, like this, what we got says you should just go from ear to ear straight. So this I should have done. You should just move 13.73 to the east, then 8 to the what? To the north, and you'll be where you're going to. This A and this is B. Instead of passing like this, like this, like this, in what direction should you go? 30.2 degrees. 30.2 degrees. Is that okay, class?
Yes, sir. Yes, sir.
Is that okay?
Yes, sir. Yes, sir.
Okay, take this one down. Determine, right, determine, question, next one. Next question. Determine in magnitude and direction the resultant of the following forces. You have to find the resultant of these forces for me. So this is 12 newtons. This is 7 newtons. This is 2 newtons. And let's add, this is
So it depends on 12 or 10 newtons.
this, just watch my hand. 7 newtons, 2 newtons, 12 newtons, 10 newtons, and 3 newtons. This is at angle 30 degrees to the horizontal. These two new things at angle 30 degrees to the horizontal. I want you to tell me the resultant of these forces, both in magnitude, direction, notation, and in unit vector notation. And give me in unit vector notation. We will start by saying summation Fs. Please, we want to find summation Fs. I will start with this. Look at the board. Everybody. Is this X force?
That's why.
Good. So that means it doesn't have X, 0. This 2, is it X or Y?
X and Y.
X and Y. Let's find its X value. What is X value? 2 cos 30. What's the Y value? What's the Y value? 2 sin 30. What's the answer, class? What's 2 sin 30? 1.73 Newton. What's 2 sin 30? 1 Newton. Look at the X and the Y value for these two. So I go for the X value, 1.73. Is it plus or minus? I'll put it. Plus. Why is it plus? Because if any force is here, is X is plus, is Y is plus. If any force is here, is X is plus, is Y is minus. If any force is here, is X is minus, is Y is minus. If any force is here, is X is minus, is Y is plus. So this force, both is X and Y are plus. So it's plus. That's 1.73 I. The idea shows that it's along the X axis. Now I come here. This 12, is it X or Y or both?
X.
Plus or minus? Plus, because it's the positive X axis. This positive X axis. This 10, is it S or Y or both? This 10.
Y.
So 0S. It doesn't have S. It doesn't have S. 0S. This 3, is it S or Y or both?
X.
Minus X. That's what? Minus 3I. The I shows that's an X value. So let's go. 1.73 plus 12I minus 3. What's that? That's 10.73I. 10.73I. The I shows that is along the X axis. Summation Fy. Let's see the Y. 7 is the Y and it's plus 7J. 2 has a Y and it's plus 1J. 12 does not have Y, plus 0. 10 is Y, minus 10J, negative Y. 3 is an X, it doesn't have Y, 0. Is it clear, class? Is it clear?
Yes, sir.
This is now 8J minus 10J, what's that? Minus 2J. So the resultant of these forces, resultant in vector notation, is simply 10.73 I minus 2J. This is the resultant in the vector notation. If you want to draw it, so you can get the magnitude and direction. If we draw it, this is Y, this is X. Where will it fall? Will it fall here? Will the result can be drawn here?
No.
Will it be drawn here?
No.
Will it be drawn
No,
here?
sir. No. No.
Yes, sir.
Here.
No. No.
Will it be drawn here?
Yes, sir.
Because S is plus 10.73. Y is minus. What will I put here?
Minus 2.
No, you are putting 2. It was the minus. It was the minus that put it here in the first place.
Okay.
If it was plus, I would have put it here. You cannot put minus 2. They are contradicting what you are doing. It was the minus that put it down here. It was the plus here that put this one here. If x was minus, I will put it here. If y was plus, I will put it here. So y is minus, s is plus. This is the resultant. That's the resultant. Is that okay, class?
Yes, sir.
Yes, sir.
How do you find the resultant in magnitude notation? In magnitude. This is in units. This is in unit vector notation. That's it. But in magnitude, your resultant is square root of summation fs squared plus summation fy squared. And that's what? Square root of, what's your fs? What's the total horizontal force?
10.73.
Good. Squared. Plus, what's total vertical force?
Minus 2.
No, don't put minus. Don't ever put minus. The minus showed us where to position the force. Don't ever put minus. Haven't drawn your diagram like this. Your diagram is well represented on the board. You don't put the minus again. The minus only show you where you will put those forces. Confirm is clear, please. Confirm is clear.
It is clear. It is clear, sir.
Good. They have punched this for me. Give me the answer.
10.91.
God bless you. 10.91 Newton. This is direction. This is magnitude. What's direction now? Direction theta equals arc tan of, we are finding direction. The direction is the angle to the horizontal, because
Yes, sir.
all the angle that we use was the angle we put, this 30 we put in our diagram was an angle to the horizontal. Direction is an angle to the horizontal in this case. You can find the angle to vertical also. I've taught you that in the previous videos. Check it. So summation Fy is the angle is always summation vertical force over summation horizontal force. It's always vertical over horizontal. That becomes arc tan of, what's your Fy? Your Fy is 2. Fy is 2. Don't pick the sign. Don't pick the sign. Then your summation Fs. What's your Fs? 10.73. They have punched this thing. This over this.
10.5.
This over this. Then arc tan of it. Answer.
10.56.
Put your unit. Represent what you are doing with a unit. This over this. 10 point.
96 degrees.
Good. I must always put degrees so I will know exactly what you are talking about. You have to put degrees. So that's that. So let's write product of vectors. 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 Right. In unit vector notation, right? In unit vector notation, let A equals xi plus yj plus zk, and B equals alpha I plus beta j plus gamma k. B equals alpha I plus beta j plus gamma k. A equals xi plus yj plus zk plus zk. Where ijk are unit vectors. Where ijk are what? Unit vectors. In the x direction, y direction, and z direction respectively. Where ijk are unit vectors in the x direction, y direction, and z direction respectively. Full stop. A unit vector, that's paragraph, a unit vector is a vector whose magnitude is 1 or unity. Is a vector whose magnitude is 1 or what? Unity. So take note. What it means is that if we represent vectors like this, xi means the vector is xi, meaning its magnitude is x, its direction is along the x-axis. If you have yj, it means its magnitude is y, its direction is along the y-axis. Same with zk, magnitude z, direction along the z-axis. Also in alpha I, magnitude is alpha, direction is along the x-axis. So what do you call a unit vector? Is a vector whose magnitude is 1. Let's go please. What's the magnitude of this vector A now? What's the magnitude of this vector A now? We have to use all of these. The square root of x squared plus y squared plus z squared. You take note of that. What's the magnitude of vector B? Magnitude of vector B is what? Square root of alpha squared plus beta squared plus gamma squared. That's the magnitude. You must take note. Magnitude means the values here. Drop the ijk. For instance, right, if vector A equals 3i minus 4j, vector B equals 2i minus j plus 2k. Find 1. Magnitude of A. 2. Magnitude of B. 3. Magnitude of A plus B. 4. Magnitude of A minus 2B. Can you hear me?
Sorry, sir, can you call those things again?
Sorry?
Can you call them again?
Yes,
Like,
I
what
said
magnitude of
question.
vector?
This is question. Here. Question. Can you hear me now?
Yes, sir.
Good. I said question. If vector A is it, vector B is it, find
Sir, say the vector.
magnitude of
Yes, say it down.
the vector K. A equals 3i minus 4j. B equals 2i minus j plus 2k. Is that okay? Are you okay with that?
Yes, sir.
So find 1, magnitude of vector A, 2, magnitude of vector B, 3, magnitude of vector A plus B, 4, magnitude of vector A minus 2B. Yeah, attempt that. I've shown you how to find magnitude. To solve the question, you were given vector A as 3i minus 4j. You were given vector B as 2i minus j plus 2k. You have been asked to find 1, magnitude of vector A. And I told you what magnitude is just square this, add them, find square root. So what's the magnitude of this one now? Square root of, tell me class, it will be 3 squared
5.
plus minus 4 squared. You must pick the sign. That's 3 squared minus 4 squared. Just pick the coefficient of I, or magnitude of I and j. What do you have? That is 5. This is 9 plus 16. Number 2. What's the magnitude of vector
We
B?
see the solution, but we are not going to make it.
Yes? Talk to me.
I'll be like, Andy.
I thought you said you don't need the negative sign.
Are you with me at all?
Yeah. We are with you, sir.
Okay. What's the magnitude of vector B now? That what? 2 squared plus, what's beside j here? What's beside j here? Minus 1 squared plus, what's with k here? K plus 2 squared. Am I correct, class?
Yes, sir.
That's 4 plus 1 plus 4. What's that, class? 3. Square root of 9, 3.
Yes.
Are you following me at all?
Yes, sir.
Number 3. Magnitude of vector A plus B. A plus B. You must first go and find A plus B. You must add vector A to vector B. How do you add vectors? What's vector A? 3i minus 4j. What is vector B? 2i minus j plus 2k. You add I to I. 3i plus 2i. What's that? 5i. You add j to j. Minus 4j minus j. What's that? Minus 5j. Then k to k. Only 1k. That's plus 2k. This is your vector A plus B. So magnitude of vector A plus B means I'm finding the magnitude of these added vectors. That was square root of, class, tell me please.
5 squared
5 squared plus minus 5 squared, Abi, plus 2 squared. That's the root of what? 54. That's the root of 54. Root of what? 54. Is that clear, class?
Yes, sir.
Number 4 says magnitude of A minus B. Magnitude of A minus B. Before we do anything, let us first get A minus B. Let's get A minus B.
A minus 2.
What is A? Oh, 2B, Abi. A minus what? 2b. Let's get a minus 2b first. Let's go and get a minus 2b. I'm teaching you how vectors are multiplied by a scalar. Please, what's your a, class? 3i minus 4j. That is our a. Minus 2 times, what is our b? 2 times b. What's our b, class? 2i minus j plus 2k plus 2k. What do we do? We have 3i minus 4j. Open this one. Minus 2 times 2i. Minus 4i.
Minus 4i.
Minus 2 times minus j.
Plus 2j.
Minus 2 times 2k. Minus 4k. So I to I. 3i minus 4i is minus I. Minus 4j plus 2j is minus 2j. This is only k. So minus 4k. So what's the magnitude of a minus 2b now? Magnitude. That will be square root of minus 1 square. This is your a minus 2b. This is it. So you are finding minus 1 square plus minus 2 square plus minus 4 square. And that's what? Square root of 16 plus 4, 20, 21. Square root of what? 21. Thank you. That is how to add vectors. That's how to add vectors. That's how to add vectors. How to find. I've shown you how to add vectors. I've shown you how to subtract vector. I've shown you how to multiply a vector by a scalar. I've shown you how to find magnitude of vectors. These are questions they give in your exams. They won't do more than this in any exam. So let's see. There are two types. There are two types of product of vectors. There are two types of product of vectors. What are they? One, we have scalar or dot product. 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 Are you following me?
Yes, sir.
Yes, sir.
Right. For two vectors A and B. Right. For two vectors A and B. The scalar product for two vectors A and B. The scalar or dot product. The scalar or dot product is a scalar. The scalar or dot product is a scalar. What does that mean? If I find the scalar or dot product of two vectors, I will get a scalar. What does it mean?
I need the place again. When you were talking, it's not
Okay, I said the scalar or dot product of two vectors A and B. The scalar or dot product of two vectors A and B is a scalar. Is a scalar. And I'm asking you, what do I mean by that? What do I mean by the scalar product is a scalar? What do I mean? Who can explain that? Who can explain that?
They have only magnitude in both directions.
Good. Who is that? What's your name? Tofumi. That's good. It means that they have only magnitude, but there is no what? Direction. That means the answer I will get when I do scalar product, the answer I will get contains only number. There will be no idea, there will be no J, there will be no K. It's just a number. Right. That is A dot B. Watch. A dot B equals magnitude of A, magnitude of B, cos theta. Put it down. This is scalar or dot product. Magnitude of A. I've taught you how to find magnitude. I've taught you how to find magnitude. Is that okay now? Magnitude of A, of B, cos theta. And this formula, right, this formula is used to get the angle. It's used to get the angle between any two vectors. Between any two vectors. It's used to get the angle between any two vectors. This formula, this particular formula, is used to get angle between any two vectors. This vector A, watch class. Vector A is this. This vector B. This is the angle between them, theta. Theta is the angle between the vectors A and B. How can we get that vector, that angle? We can apply this formula to get that angle. That angle is what? Cos theta equals A dot B all over magnitude of A, magnitude of B. If I make cos theta the subject of the formula. If I make cos theta the subject of the formula. Is anybody following me?
Yes, I'm following you, sir.
Good.
Yes, sir.
Yes, sir.
Good.
Yes, sir. Yes, sir. Yes, sir.
Good. Yeah. If we can use this to find angle between two vectors, it means I will need magnitude of A, which I've taught you now. I will need magnitude of B, which I've taught you now, but I've not taught you. How can we get A dot B? How can we get A dot B? So, if A is, watch me in class, is xi plus yj plus zk, and B is alpha I plus beta j plus gamma A. If these are A and B, if these are A and B, then what is now A dot B? How do I get A dot B so I can use it here? See, A dot B is always I to I. That's alpha x times alpha, I to I, y to j, y times beta, k to k plus z times gamma. This is how to find A dot B. Let's see what example. See the question here. If A equals 3I minus 4j and B equals I minus 2j plus 2k. If A is this and B is this, what is find A dot B? Find A dot B. What is A dot B? That is what I taught you just now. Here, see the board. How do we do it? See the board. A dot B. I here 3. I here 1. Have you done? I in this place is 3. I in this place is what? 1. J here minus 4. What's J here also? Minus 2.
Minus 2.
God bless you. What's K here? What's K in this place? Anybody?
0.
0. What's K here? 2.
Plus 2.
God bless you. This is now what? 3 plus, you got minus 4 times minus 2 is plus 8. 0 times 2, 0. Answer 11. So A dot B is 11. A dot B is what? 11. It's 11. It's 11. Is 11 a scalar or a vector?
A scalar.
That is why we said The scalar product of two vectors is a what? A scalar. It's always a scalar. Good. So let's go. Let's do this assignment and stop here for today. Is that okay? Is that okay?
Yes, sir.
Yes, sir.
Okay, yeah, take this one down. Given the following vectors, A equals I minus 2j plus 2k, B equals 6I minus 8k, and C equals 3j plus 4k. This assignment, find the following. 1. Magnitude of A, magnitude of B, magnitude of C. 2. Magnitude of A plus B minus 3C, magnitude of 2A minus 3B. Magnitude. 3. Angle between,
Excuse me, sir.
yes, A and C. Yes, I'm with you.
What did you write in this C?
A equals,
3J.
I will call everything for you now. I will call everything again.
Alright.
A equals I minus 2j plus 2k. B equals 6I minus 8k. C equals 3j plus 4k. Confirm you're okay.
Put the B again.
Is that okay?
The B.
B is 6I minus 8k. Is that okay?
Yes, sir. Yes, sir.
Thank you. And find the angle between A plus B and A minus B. There are 5. Find A dot B cross C. I've not taught you cross product. This is, hold on, watch class. Can you see number 5? Number 5 is A dot B cross C. But I've not taught you cross product. I've taught you dot. I have not taught you cross. So read up cross product. Is that okay now?
Yes, sir.
Go. We now find A dot B cross C against next class. So next class, I'll be taking you number 2. Vector product or cross product. And that'll be the end of vector.